All right. Hello, everybody. Welcome back. This is another Python project explanation. This one is for the final project for the CSC3 Programming for Everyone 2 class. The project here is pretty straightforward. It's a combination application of pretty much everything we've done up to this point. We're going to take some data out of a website, specifically some world meters, coronavirus information, put that data into a CSV, move it to a database, make some queries, polish our data, save it back to a much more clean and polished CSV for various use, do some statistical analysis, and then graph some data. And then obviously this part of the presentation. So we're going to go ahead and get started. First thing is always take a look at our source. So here's our source. This is the Worldometer's information on COVID. Up here you can see a pseudo live count, some quick, easy information to see, some graphs, which are kind of interesting to look through. But the section we're actually interested in here is what I was looking at earlier, is the table of data. Clear that pop up. And this is a sortable table, presumably from a locally stored database, which we could have access to, problem solved. But what we have is this nice table of data, and it's sortable in a lot of ways, including you can sort by continents. And then there are some other tables for previous data, and these are completely different tables. And then there are also some hidden columns off to the side here. So you see at the end, it ends at population, but there are actually 6 more columns to this table that we can see over here. So here's a little bit more information for you. Also included in this that they don't show you because they're hidden rows and columns is there is a column that is an identifier for which continent it is in, presumably to use for the VLOOKUP of sorting by continent. And then also included is inside of each of these rows is the continent data itself. So since, let's get an example here, South America is a little bit lower than USA, it actually slots in right there. But you don't see that on this table because it's just designed to show you the countries. So that's kind of the information we're looking at. If you want to look at the source HTML, the Control-Shift-I function always works in Chrome. There's a lot of stuff here. And then we get into the elements. Let me try to find, I'll just do this. So our table here is ID'd as main table countries today. And then we've got our header. And then we get into the actual body. And the body is all the data that we're actually interested in. And you can see that it includes everything. And still you don't see it, but it will include all of our hidden rows. You see, if I hover over these, we actually, you can see that it is a data continent and not a data country, is how that is labeled. So that's how our data looks. Let's get into the actual script itself. So here's the script. We start with our requests or our imports. We're using request, CSV, Beautiful Soup, SQLite, and then this is all for making CSV and importing the data. And then we've got pandas, numpy, matplotlib, and then scipy. These are all for some calculations later that we'll see. So first we're defining some variables. This is our website URL, so we don't have to type it later. And then these are the names of our files that when we run the script, you'll see pop up over on the left side of the screen. And I actually have cleared all those files so we can see them get made all in this one script. So this is all compacted into one script. We have our first function that takes the Beautiful Soup contents and makes it into our CSVs. We have it split into country CSV and continent CSV respectively. Could probably do that later if we wanted it all in one data, but the data sets are structured slightly differently. So I've decided to do this like this so that the data is easier to use later down the road. This whole script is to make our data usable, and then using CSV and those functions to get our data actually into our CSVs. One thing that I found is that the way our data is laid out, if we just ran this chunk of our code without the if data statement, we would get an empty row every other row. Not sure why that was, couldn't figure it out, but I decided to just implement this if data, which basically checked if there was anything within the current row. And if there wasn't, we skipped it and moved on. And then if there was, then we wrote it to our array, which worked out pretty well. Optional to write to the array. I decided to because since I'm doing this all in one script, saving the array as a variable for this whole script made it easier than reading the CSV every time I wanted the data. So if I just kept it in this array form, it was easy to clean it later and then make a new CSV with that data. So there's our first function, and it returns the arrays to the main loop. Next up is our create database. This is handling our database files. Notice that we are using the arrays and not the CSVs. Like I said earlier, the arrays are just already imported into Python. They're already stored in our loop. It's easier to just use them as opposed to writing a read script to get our data back out. We already have it. Let's just use it. So our arrays and then db file. This is just the name of the file we want to store. We stored that up here earlier. So we grab that, grab our cursor. I'm actually going to take out right now. I had these in for when I was cycling through running tests on this, because if you don't have this in here and it tries to create a table that already exists, it pumps out an error message. So for the first time running this, you don't need it. There's probably a workaround. You can use the try function or the try conditionals, all that. But for my purposes, I just comment it out the first time you use it, or if the file doesn't exist yet. And then when I'm recycling it, I will take the comments out and try it again. So we make our tables. These are all the names of our data. The continent one has a lot less information because the way the continent array is laid out is it's just using the summaries of the continents, which doesn't have all of the specific data. The rest of it can be calculated from each country and averages and all that. So this is our continent dimension and then our country fact. These will be joined by continent dimension ID, this one right here. It's in the table at this entry on the data, so it's all the way down here. But at the front, I just throw it as an integer. And it is conveniently already numbered in the data, so we don't need to do the auto increment like we do for country ID. And then this is cleaning our data a little bit more. So for the continent names, Australia, Oceania is referred to as just Oceania, but in all of the continent IDs in the country data, it is labeled as Australia/Oceania. So that is finding the entry of Oceania in the continent array and changing it to the usable Australia/Oceania. This is replacing all of our blank entries and NA entries with zeros, and then converting all of our string values to integer values. Some of them have decimals for some reason, which is why we have to throw in this float and then into an integer, because I didn't want to have to go through peeling off everything after the decimal point. It was easier to just have Python see it as a float value and then have Python see it as an integer. We don't have big enough numbers for it to really break much here. So this is my solution for that. And then we go ahead and do our SQLite, XUmany, and then this handles all of the data in the array. So this for loop handles our continent array and then inserts it into our database table. And then we do the same thing for our country array. First, what we do is now that we have our continent array, is we replace all of the continent labels from our data with the ID that we made, the continent dimension ID, from our previous table. There are a couple that are not associated with a continent. For those, we just replace it with a 0. But if it does exist there, then we replace it with that. And then the same thing, we remove all the empties and NAs from our data. And then at the beginning, there is a incremented ranking that is sorted by however the table is sorted initially. I believe it's by total cases is how this table is sorted. Let's check that. Yeah, total cases. So this is how the table is sorted initially. And then it's got this ranking over here. So we don't need this column. So we throw in a pop and we remove column 1 from our data. And then same thing as up here, we change all of our string values into integer values. Again, there's not rounding, it's all integer based here. So we can make it all integers. And again, the values are not quite high enough to worry about changing it to a float and then an integer. And then we throw in our execute many, which this is a very long set of data. So there are quite a lot of variables. And then last thing, we also don't want to include the first column. Huh. Yeah, I see why I needed this now. Let's just pretend I never did this. Yeah, you know what? We're sticking to our guns. We'll leave it there. It's useless because it's not actually defined, but you know, whatever. And then we commit our changes. And then once we've done that, we use our pandas to read the SQL, pull our tables, and then store them to our CSVs. And so these are our polished CSVs. And then this again, we've defined at the beginning of our script up here. So these will be the file names for when those are done. Last up is plot stuff. This one is pretty straightforward. There's a lot of data here, a lot of information to be used. So I just pulled a couple that I thought might be slightly interesting and plotted those. But realistically, there's a ton of data. You could spend forever doing data analysis and graphing things, but these are just a couple examples for implementation of matplotlib and some other math functions. So this is our last function. We reconnect to our database, and then this is our first execute. We're pulling the continent names, the number of countries. You'll see this group by is by continent dimension ID. So this is the number of countries on that continent. Average of cases per million for that continent. Or sorry, average of cases per million for each country in that continent, and then average of deaths per million in that continent as well. And we're storing those. We define our abbreviation for a country fact. We join them on the continent dimension ID, group by continent dimension ID. So this gives us all of our continents grouped. And then we sort them by average cases and then by average deaths if there was a tie. There's only 6, so I don't think there's any ties, but just in case. We actually don't really use this. If we want to, we can replace this index with from 2 and replace it with 3, and that will give us a list of deaths instead of cases. So if you want to see that comparison instead. And then we set up a nice simple bar graph, nothing too complex, pretty straightforward. And then our second one is total cases, and then we also have cases per million, but this is sorted by country and then ordered by cases. We also included population if we want to do some more calculations. But in this case, there's some countries that have no people. The population is 0. If we scroll all the way to the bottom of this, I think we can see one. Yes, so let's scroll over to population. Diamond Princess and MS Zandam, I don't know how to pronounce this. Population 0. And some weird numbers for the rest of this. I don't really know what's going on with those two countries, but it caused some problems if I do some division by 0, especially up here. And I had some points where it was division by 0, and I was like, those feel like, I don't know, there's like, 3 countries, not many countries with population less than 100. They're the only ones. So I didn't feel bad doing this. If you want, you can fine tune this. You can go up to 10,000, just get rid of some outliers. For a couple of these, I ended up actually removing the top end because India and China are some outliers in population. And then for total cases, USA has more than double any other country for a lot of other things. So it just felt like including some catches for outliers. Maybe polish the data a little bit. It makes it skewed a little bit. But in the case of like normal distributions and whatnot, kind of gross. So I threw this in, and we're only including the cases that meet these criteria, and then we set up a graph for that. So for this one, I did a plot, and I included a normal distribution, which this data is not a normal distribution. We're just going to throw that out there. If anything, it's probably closer to a chi-square distribution, but because of the size of the variance, which you'll see in our print statements here, which is our final calculations of statistical analysis, is mean of our total cases, variance of our total cases, and standard deviation of our total cases. It's just a lot. So you're going to see that as we run this. I actually, I think I said this earlier, but I haven't run this, or I deleted all the files so we can see everything get generated in real time and then go back over it once through and make sure that everything is as it should be and all dots in its place. So that's the whole function, or that's the whole script. In the main loop, we call our functions one at a time. I did it like this in case I wanted to create a separate script that was just one function. But eventually what I ended up doing is like, oh, I have my databases created. I just want to plot stuff. Let's just comment these out. Nope. Let's just do this. And so that's what I ended up doing. But I made it like this just in case. So let's go ahead and run this and see what happens. So if we run it, I'm probably going to have to do some bug fixing in a second. I don't know why, but I just feel it coming. Oh, it actually worked first try. Okay, so we get our two graphs. This is average cases. This is per 100 people. You saw the division by 10,000 up here, I think. Because this data is actually in millions, cases per million, but these numbers just got way out of hand, and we didn't, it's the same data, it's fine, we don't really need to see that. So I divided it by 10,000, this is now cases per 100 people. You see that Europe has the highest average with about 39-ish. Australia, Oceania is actually next with about 23, 22, 23. North America not far behind, and then slowly down. And then this is the interesting one. This is total cases for each country. Yeah. These are big numbers. And this is America over here. It's a weird graph, and it doesn't really, like, it's hard to graph this data because let's take a look at our stats for that data. The mean is about 3 million. Sorry, I'm catching a cold. We'll go to standard deviation, 9.68 million, which our variance, which is our standard deviation squared, I believe this is in the trillions. I think this is 93 trillion, I think is what I decided. Yeah, a lot of variance. So kind of hard to use that for anything meaningful. But that's the variance. So that's our statistical analysis for the total cases per country. And then you can see over here we've got some files that popped up, continent, country, and then our source CSVs, and then our databases here as well. So let's actually take a look at this. If we look at our first, I'm going to open this in Excel actually because it's a little bit easier to look at than Python's or PyCharm's CSV viewer. So let's go ahead and open this in Excel. So here is COVID country data. And it has this issue where the numbers are too big for the columns. So it does this numbers thing, but the values are there. So we include a world, and then you can see all the data here. Here's our hidden column of the country, if you didn't believe me. And you can see that it is labeled as Australia, Oceania, which is why we had to do that correction earlier. And then we've got some blanks, and we've got some NAs. But what this doesn't show you, and what took me a little bit to figure out, is if we go back to our script, and we actually do use Python's built-in viewer. Sure. You can see that these values are strings, which took me longer than I'd like to admit to figure out. So that was what I had to go do the integer and float and gabagoo for. But then if we go to country final, looking at it in Excel first, you can see the big numbers are rounded off, but plenty notable, so it is okay. I don't know why it does it like this here. I think it's because they are values now. They're actually integer values instead of strings, and it was a little confused on that. But you can see that as you close in on it, it shows you the scientific notation as opposed to hashtag, hashtag, or pound, 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 pound. So yeah, this is our polished data. We've removed the world row and added our labels for what each value in the table is called. These are our table values for our database. So this is a lot cleaner. And then again, if we go and check it out in here, you can see that they are values, they are integers and not strings, which makes it usable data. So there you go. There's our files, and then our database is right there. If we look at our continent one, much smaller, just the 6 continents. Australia is not in here. No, Antarctica is not on here because there's nobody there. There's like 6 people there, I think, on the whole continent. So yeah, that is everything. I believe I've covered everything that I needed to for this. This was a pretty interesting project to work on. Lots of hiccups as always. It's super enjoyable. I really learned quite a bit about how to implement everything. And after talking to, when I first read this description of the assignment, I was thinking make a CSV and then a database and then another CSV. This feels redundant. But after talking to a couple of people who are actually working in the computer science and data science fields, the first thing he said was, yeah, this is all really practical, and this is exactly how you do things in that world. You make your source. This is one that you don't edit, and you always have as a reference. And then your original database. This is your first iteration, or maybe it's the one you use all the time. And then once you polish your data, you make a new CSV. And then you have that polished data for if you need it later. It's like, okay, that actually makes a lot of sense. So this is all very practical things, very useful strategy about going about this. At first, I didn't realize it and thought it was redundant, but hey, that goes to show my lack of experience, and it was really nice to know. So yeah, this was a really fun project to work on. Thank you all for tuning in. This was a little bit longer video, I know, but this had a lot to go over. So thanks for sticking with me if you did. Otherwise, I don't know. Thanks for not being as much of a nerd as me. I don't know. This is I've done YouTube videos too long and I still have no closure. So, yep.